Hi everyone, welcome to section 4.2, which deals with graphing linear equations in two variables. So what are the objectives of this section? Recognize the relationship between solutions of an equation and its graph. Also graphing linear equations by plotting points, and then graphing vertical and horizontal lines. Okay, so first thing is, what does the graph represent anyhow? So suppose you took the line 3x plus 2y is equal to 6, and you plugged in some points, and you solved for values of x and y, and you got a set of 3 points here, 0, 3. So these points are called solutions of the equation, but those aren't the only solutions possible. If I draw a line through these points, I actually have this line right here. This represents all the solutions. So there's a point here, here. All these infinitely many points. It goes on till forever. That's what this arrow means here. It keeps going and going. That's a set of all points that are solutions to that 3x plus 2y equals 6 equation. Okay, so let's say here you have, if you have negative 2, 6 here, if you plug that in, you'll get that it's true. 3, but what about if I plug in 4, 1 over here? You'll see if I do the math here, I plug it in, I get this 14 equals to 6, which is not true. So 4, 1 is not on the line, and it's not a solution, okay? All right, so the graph of ax plus by is equal to c, where a, b, and c are numbers, is a line, okay? So every point on the line is a solution of the equation. Every solution of this equation is a point on the line. And so now here you can see how nicely it is that this picture and this sentence, algebraic representation of that, they fit together very perfectly. So, okay, so let's say here I have the graph y equals 2x minus 3. So for all these ordered pairs, we need to decide if it's a solution to the equation and is a point on the line. So for A, 0, negative 3, so we're going to plug in, so remember this is x, this is y, so plugging it into this equation, we get negative 3 equals 2 times 0 minus 3. So yes, that works. 0, negative 3 right here. And then you can also check graphically without even plugging it in. So 3, 3, so 3, 3, yes, that's a solution. And it's a solution to the equation, and it's a point on the line. So it's yes and yes. So yes, yes, for these two. And what about 2, negative 3? So when x is 2, y is negative 3, that's over here. That's not on the line, so no, not a solution. Okay, not on the line. See, it's over there. How about negative 1, negative 5? Negative 1, negative 5, yes. So yes, it's a solution. Okay, and yes, it's a point on the line. Okay, so let's see here. Same thing. If it's a solution to equation, a point on the line. So 0, negative 1. So that's right here. And yes, it is, right? 0, negative 1 is a point on the line. So yes, it's a solution. So you can use the logic both ways. You can say, oh, if I see that it's on the line graphically, then I know that it's going to be a solution algebraically. Okay, so 2, 5, it's up here. So yes, that's also true. Okay, so so now that we see that they're connected, how do we graph a linear equation by plotting points? Okay, so let's say here you have an equation. So then you find 3 points where coordinates are solutions to the equation. So organize them in a table. So first you would have to figure out what those are. So you would draw a table. So let's say here we have 2x plus 1, y equals 2x plus 1. So I'm going to choose negative 1, 0, and 1 for x, and then see what I get for y. So plugging this into y, I get y is equal to 2 times negative 1 plus 1. That's going to equal, that will equal negative 1. Okay, if I plug in 0, I'm going to get 2 times 0 plus 1. That's just equal to 1. And then if I get 1, for x, I'm going to plug that into the equation. Y equals 2x plus 1, so that's going to be 3. So now I have the points negative 1, 0, 1, and 1, 3. Remember, x first and then y. So if I plug this in, so here's my coordinate plane. It's not perfect, but let's just say here I have 4 in this direction, 4 in the negative x direction, 4 in the positive y direction, and 4 in the negative y direction. Okay, so this is y, this is the y-axis, this is x, this is y. Okay, so then if I have -1, -1, I know this is 0, 0, so I'm gonna go down 1 and down 1 here. So that's gonna be this one, -1, -1, okay? I'm gonna erase this little, oof, sorry, I did not mean to do that. I meant to erase the dot I made in the origin. Okay, so then what about 0, 1? That's the next one. So x is 0, y equals 1 is up here. This is 0, 1. And what about 1, 3? So x is 1, y is 3 is up here. So 1, 3. So the point, this equation, y equals 2x plus 1 goes through here, these 3 points. Okay, so that's how we graph by plotting points. We graph an equation, we figure out 3 points using a table, and then we graph it. All right, so that's this one. It only takes 2 points technically to determine a line, but you can use 3 points. It's a good habit because you can see that if you only plot 2 points and one of them is wrong, you can draw a line, but it won't represent the actual line. It definitely will be wrong. But if you use 3 points and one of them is wrong, the points will not line up. So see, like here, these points do not line up. That's because they're not on the line. So you need to figure out what's wrong, and you need to check your work. Okay, so let's do this here. Graph the equation by plotting points. Y equals -4x. I'm going to do an XY chart. I'm going to let x be, -1, 0, and then 1. Okay, so in this case, y is going to be -4 times -1, which is +4. Here it's going to be -4 times 0, so that's 0. And then here, -4 times 1 is equal to -4. So you see, you have 3 points here. We have the points -1, 4, the origin, 0, 0, and then finally 1, -4. Okay, so you have those 3 points that we need to graph. So let's go ahead and plug that in. We have -1, 4 up here. So this is -1, 4. Sorry, I don't know why I put 5. And then the origin is right here, 0, 0. And then you have the third one, which is 1, -4 down here. 1, -4. Okay. So then we go ahead and we connect the 3. Here we go. And that's the line y equals -4x. Okay. Let's see here. We'll do one more.